In this case, I've just got them as flat parts. And then the way they get joined together along the edge for chair number 2 is welding these parts together.
Any particular type of welding?
It'll depend on the material you're using. You're using steel for this one. So what that would be MIG. Yeah. There's always somebody in this class that knows more about welding than I do. So this welding is very expensive. Not only do you have to build fixtures to kind of hold everything in place while you're welding these unusual shaped parts together, but it's time consuming because it's like doing bodywork on a car or building an industrial design model. Once you weld that, then you need to grind it. Very often you have to fill it. And you have to fill it with, because we're going to be powder coating. Powder coating requires electrostatic charge, so you need to use a Bondo that has a metal in it. It's made mostly out of metal. And that stuff's really expensive. I think it's like $100 a tube or something like that. Roughly, this welding is $1 an inch. Just kind of a good little rule of thumb. That includes the grinding and finishing and stuff. So I want you to calculate the number of inches of edge welding. Okay, so now you'll notice that this only bends in one direction, just like the acrylic project. It bends in this direction. In this direction, it's straight. You can choose either direction you want to bend it, but it can't bend in both directions. It cannot have a compound curve. And one thing you can do is sort of fake a compound curve. For example, this back piece here, it's got a curve going this way and a curve going that way. So it's like that, right? But you could cut a circular shape or semicircular shape on the back of the chair. Like that. Okay. Go late. Next. Okay. So this is still just curving in one direction, but it almost gives the impression that it's a compound curve because the flat part looks like that, and you can even make the flat part look like that if you wanted, and then you could wrap your other piece of metal around that one. And weld the edge. You just have to, again, remember that none of these pieces can bend more than one direction. Is that understandable? I want to make sure that one's really clear with everybody. Okay. Now, when you have these two pieces, the next thing you're going to do is you're going to powder coat these parts. I'm sorry, you're going to put your press-in fasteners. So press-in fasteners is a lot like the rivets. So these are the PEMs that I was talking about. So in that case, what you do with the PEM is you take the sheet and you punch a hole in the sheet, and then you take your PEM fastener, which usually has, so say this is a nut. I'll explain to you why we might do something like that. So you want to press that down into this hole. And so it's a little bit bigger than the hole that you drilled for. It's kind of like self-tapping, right? And on the outside, it's got knurling on it. So you push that thing down into the metal, and then it clamps it in place. Because the metal gets deformed, and you end up with your PEM sitting in here like this. And it's locked in mechanically. So you know how a lot of guys are trying to lock in your extrusions that way? And I told you couldn't do that? Well, you can on this one. So you'll be smushing these pen fasteners into the hole that's been punched in the sheet metal. Now the reason why we might do this is because if we were to do a self-tapping hole, we know about self-tapping screws, right? We've already talked about those. You have a very coarse thread and it makes its own threads. That works pretty good if you're only going to screw something in once, maybe twice. But eventually you're going to mess up those threads when you take them in and out. And it could even happen on the first one where you mess it up. And so if you have a very expensive part and you know you're going to want to take it apart or put it together in a nice way, you don't want to use self-tapping screws. In that case, you want to use a pen. So this has its own threads inside the pen. And those threads can be made out of a harder material so that they don't get mucked up by the screw. So that's how I want you to join your pieces of your chair together. So here's the seat of the chair, and then here's the back of the chair. One of these would have a pen in it, and then you come in with a machine screw on the other side and thread together. I'm showing a section view. That's the back of my chair. It's kind of like that. So that would all be hidden. And so this is nice, again, if you're going to take something apart. Maybe you want to ship it or something in a box and it doesn't fit nicely in a box. You can take the two parts apart and kind of find a nice way to fit them into a square box, and then the customer can assemble it when it arrives from Amazon. Now the finishing process for this one is going to be powder coating. Powder coating is where you attach electrodes to the metal part, and then you spray a powder. Man, I'm going to get through most of this lecture today. This is pretty cool. Okay, so let's talk about powder versus paint. So powder coating is, again, you attach the electrodes that attract the powder. You spray the powder like with a gun, like you would with paint, but it's a dry powder, and then it sticks to the metal part, and then you melt the powder in an oven. So you end up with a super durable finish.
Is that anything like Parkerizing?
I've never heard of Parkerizing, so I don't know.
They do it on like gun barrels and things like that, or that have to have like really high heat as well.
Oh. On the outside of the gun barrel?
Yeah.
Yeah, I don't know. But probably, I bet it is something like that. So almost all appliances are powder coated because of the durability. Right? So you don't want to scratch up your refrigerator, your dishwasher, your washing machine, whatever, and the powder coat is much more durable. So then you ask, okay, if it's more durable, then why wouldn't we use it for cars? And the reason is because you can get a much better aesthetic finish with paint. Powder is more consistent. It's really kind of brainless. You know, a monkey can do it, right? It's like teaching them how to point the gun at the part. Because this powder just sticks to it, and then you melt it in an oven, you get what you get. You're going to have a consistent finish every time. But, you know, where with paint, as any of you guys have known, even if you just use a rattle can, but if you've ever used a spray gun, there's so many variables to what kind of finish you're going to get. The amount of air pressure you have on your gun, the viscosity of the paint, the direction that you move your arm as you're painting with the gun, the humidity, any particles that might be in the air. There's just so many variables that make painting a nice aesthetic finish a nightmare. But once you get it, it looks really awesome, right? So if you're looking for aesthetics, paint is the way to go. You also have a wider variety of colors. You can get any color in the world, right? Powder, unless you want to order a huge quantity, you're limited to maybe about 50 colors, something like that. 50 standard colors. Paint is also better if you want to touch up. So if you get a scratch on your car, you can get some touch-up paint and fill in that scratch and buff it out and get it looking almost back to new again. You can't do that on your washing machine, and that's why you can sometimes get really good deals at appliance stores, because the washing machine has a scratch on it. They can't fix that scratch. So, and the reason why is, again, the process uses the electrostatic charge, and the material typically is what's the word for it? Besides being durable, things don't stick to it. I can't think what the word is for that. Okay, let's just say paint won't stick. So this is actually a con, right? This is a bad thing, because you can't touch it up. But that can be a good thing. They use it in playground equipment. A lot of times they'll use these materials like a polypropylene or polyethylene based powder. And so if somebody sprays graffiti or something on playground equipment or something like that, they can wipe it down a lot easier than if it was a painted finish. Powder is much better for the environment. There's practically no waste. The powder sticks to the part. Anything that falls on the floor, they can sweep it back up and use it again. Nothing goes into the environment. You're not putting fumes and vapors and stuff like that out into the environment, and that have to be filtered, because there is none of that going on. So it's much better for the environment. It's also cheaper. So powder is really a wonderful thing, and it's being used more and more and more these days. When I was your age, I think there was like 6 powder coat colors available. So designers didn't choose it very often. It was mostly just used for machine tools and things like that, where you needed that ultimate durability, or for appliances. But now, like I said, there's maybe 50 colors available, and you can get customs if you have a big enough order. So, because it's really got almost everything going for it from a manufacturing standpoint. It's very durable, it's very consistent, it's environmental, it's cheaper, it's really kind of wonderful. Unless you just need that show car finish, then you're probably going to want to go with paint. Yes?
Is it possible to polish powder coat?
Depends on which type of material you're powder coating, you might be able to do that. The other thing that happens with powder, when I talked about consistency, you can also get textures. And so you don't have to paint the texture on, which you'd have to with again, if you guys have ever built an industrial design model and you wanted to have a texture, you have to try to control that texture. With powder, you can just specify that you want that texture, and it'll be built right into the paint, and it'll just, or into the powder, and you'll end up with that texture. You can also, metallics. Metallics and pearls. These are really problematic with paint, because those particles in the paint are heavier, so they tend to sink to the bottom of the can, and if you don't mix it up well enough, you paint one part one day and you paint the next part the next day, and you put them next to each other and they're not going to match. I've had many clients that have asked for a metallic paint job, and then they see it and they're just like, oh, you know what, our manufacturing people said no, we can't do that because we can't handle the rejects. So my answer always is, okay, then let's powder coat it. And so powder coating is really wonderful from that standpoint too. So more and more, I would recommend powder coating as a really good choice for painting metal parts. Can't paint plastic parts with powder or coat them. It'll melt the plastic in the oven. Let's see. Go back to the first page and see if I missed anything. I haven't done the one-pagers, but that doesn't matter. We can do that on Tuesday. Yeah, so for this project in general, I want you guys to find a gauge chart. and print it out. And then tell me what gauge you're using and what that thickness is. So I'll give you an example here. I could just give you a chart, but it'd be better for you to go through this process because someday you're going to need this chart and then you'll know how to find it quickly. I won't say sheet, I'll just say metal. This is the craziest thing in the world of manufacturing, I think. So check this out. 14 gauge, 16 gauge is pretty common in steel. So this first one is steel, which is like our cold rolled steel. So if you go down this chart, look at 14 gauge steel, it's 0.0747 inches thick. Okay, so a little over a 1/16 of an inch. That's probably pretty good for a chair. Right around 14 gauge, I think.